They recently entered into an agreement to supply BMS to Barcelona-based Ray Electric Motors. Such agreements are a proof of the high-quality integrations that India can offer. Our first guest, Mr. Indresh, is a part of the Clean Energy Analytics team at Ion Energy. He is a man on a mission, and that is to help businesses transition into clean energy by the use of analytics. Our second guest, Mr. Suraj, is a part of the functional safety team at Ion Energy. He is an ardent learner who likes to share his knowledge and expertise in many forms. He has also published a course on startups on an academy. Today's conversation will focus on battery management systems and battery data analytics. So we look forward to this very interesting and insightful session, and we welcome both of our guests on behalf of Team Gyaniki and today's participants. Welcome Mr. Indresh and Mr. Suraj.
Thanks, Ashwath.
Thank you, Ashwath. Thank you for the brief introduction.
Suraj, you are starting, right?
Yeah, allow me to share my screen. I'll start. Let me know if my screen is visible.
Yeah, it's loading on my end, sir. So let's wait for a few seconds. Yeah, it's visible now.
All right. Thanks, Shashwat, for the brief introduction. My name is Suraj, and I am functional safety expert and program manager at Ion Energy. Just a little introduction. Ion Energy is a tech company with having advanced hardware and software platforms for its battery management systems. Ion Energy has been supplying to 60,000 plus customers across 12 plus countries with its advanced BMS platforms. And me and Indresh are taking care of battery intelligence and battery analytics technologies, respectively. Okay, so with that introduction, I would like to give you some brief of what Ion Energy is doing and what challenges Ion Energy facing day to day. Not sure why, but my screen is stuck in the same slide.
So you can if you have using slideshow mode, you can go out of it and then you can change the slides. So that would be better.
Okay, so with that, let's start with few of the amazing features of BMS that Ion Energy offers. And one of them is BMS is something which is going to compliant to the international standards called ISO 26262 functional safety. This is one of the automotive safety standards that each and every OEM is looking for and expecting their suppliers to have compliance with. What does exactly ISO 26262 mean? ISO 26262 deals with any internal errors which will lead the system to such a state which is not beneficial and unsafe for human and traffic participant objects around the vehicle. And it's important that we categorize all the possible types of errors and categorize them into whether they are safe or unsafe. Ion is building its BMS platform with ASIL C and above categories of safety. If you see a figure on the left side, you see that there are multiple batteries, out of which every battery has a different SoC connected together across in a common bus bar. What Ion offers is, if any of the battery reaches a level where it has identified that there is an error which will lead to a functional safety issue, then all of the batteries are disengaging it. So we offer the safe state where none of the battery is engaged and the vehicle is basically safe and free from the battery level hazards. We also see that if the battery is operating in the safe operational area and if there are overcurrents, short circuits, or over voltage, over temperature scenarios, which is leading the battery to out of the safe operation area, then we disengage the battery from the system. We also take care of the loss of acceleration because of the batteries disengaging due to functional safety issues. Or we also take care of the sudden jerk, which we are preventing it basically if there is a sudden engagement due to any internal error. Then we see there is one of the core features in the IONS battery management system, which is paralleling. So what's paralleling basically mean is when there are different batteries with different voltages on the same bus bar supplying to a common load, if we connect or engage two multiple batteries together, what will happen is there will be a sudden rise of current from the higher voltage battery towards a lower voltage battery, and instead of supplying to the load, it will end up supplying to another batteries, either charging or discharging them, or end up reaching a short circuit current. To avoid this, ion BMS communicates with all the batteries and keeps them updated constantly, keeps them updated real time so that they share the battery voltage. And while discharging, only one of the batteries with the highest SOC or highest battery voltage shall be engaged, while the other way around, if the chargers are connected, then the battery communicates and the battery with the lowest SOC or the lowest voltage shall get engaged, while others remain disengaged. So our batteries not just share the voltages, but there are more than 15, 16 parameters of individual batteries that they are aware of each other while they work in conjunction in a common network supplying to the common load. The third feature that our battery offers is our battery management system offers is an authentication. So it offers a security against a hot swap of unauthorized battery. What does this mean is if the vehicle is on and if I pull out one of the batteries from the vehicle and hot swap the other unauthorized or stolen batteries, then the rest of the batteries will absolutely not accept the battery because it belongs to another family and the system will refuse to work. Similarly, if all the batteries are swapped in the vehicle, with which all the batteries are not supposed to work because the vehicle is stolen, then the batteries will end up refusing to work with the vehicle. So this is it also offers one of the features that an owner of a vehicle basically can purchase multiple batteries and use only few of them in the same vehicle in a fashion where it can charge and it can charge the batteries at home and discharge it while using the vehicle. So these are some of the authentication features that BMS offers to battery and the whole vehicle ecosystem. And with that, maybe I would like Indresh to take up with the rest of the slides from the analytics.
Yeah, sure. Thanks, Suraj. That was great. Let me share my screen and then we can talk about. So, should be coming up now.
Yes, it's visible now.
Okay, okay. Okay, so what I'm going to talk about is uses of data analytics in improving battery life and performance. So my friend Suraj spoke about how batteries are managed by the BMS, and BMS is inside of the battery. But you can also manage the batteries from the outside of the battery by using analytics on a cloud computing. So what I'm going to cover is how batteries' life and performance can be improved outside of the battery using cloud computing and data analytics running on cloud computing. So any battery, any lithium-ion battery working and managed by a BMS generates a lot of data. These data could be current, temperature, voltage, the charge levels. And like I was saying, that there are two ways in which you can make sense of this data. Embedded computing is BMS, the battery management system. It's a small hardware, it's a small electronics which is inside of the battery itself, but it has certain limitations. The limitations are that it's a low power device, it's a small computer, it's a very small memory, so it cannot really do any advanced analytics. So any output that we receive from an embedded system will be limited. In contrast, if we extract the data through IoT and then analyze that data on a cloud computing environment, then it's more scalable. And also it allows you to run more complex algorithms, which could be machine learning algorithms, which could be advanced statistical algorithms. But it takes away the constraint of a small computing environment, and you are free to do any kind of analytics that you want to do, which results in a more advanced output. So what are the outcomes that we intend to achieve? So this is a sample of the analytics dashboard that our customers make for themselves. So this may contain analytics like the battery's state of health, capacity, the temperature distribution, the current distribution, voltages, and then some more modeling also can be done on the data. So there are two ways in which you can use data. One is to visualize it, and second is to make interpretations out of it by using different models. So let me take you through the modeling part, which is a core of analytics. Uh, so when you go beyond simple visualization, you enter the realm of development of models, and that's the most interesting part that we can cover in this talk. So this is a 2x2 matrix where on x-axis you have time to market. Time to market is the speed at which something can be delivered to the customers. And on y-axis is operational improvements. So what are the business outcomes that can be achieved for a customer? So the first modeling that we do is empirical modeling. This is faster. It requires less time for development and is very helpful in managing business operations. But the second modeling that is common in the industry is electrochemical modeling, because we are dealing with batteries, so it's electrochemical modeling. This is mostly useful in the design phase compared to empirical modeling, which is in the operational phase of business. But this has a slower go-to-market, so it takes time to develop these models. The third modeling is data-driven modeling. So this has the advantage of being more accurate, but to develop this, you need a lot of training data. You need a lot of data to be fed into the model so that the model improves in accuracy. In case of ion energy, because we manage a large amount of batteries, large portfolios, multiple assets of different types, we are able to do data-driven modeling much faster, simply because we have access to more data globally, different types of batteries running in different kinds of applications and environments. So we are able to deliver data-driven modeling at a much higher speed and also at a much higher accuracy. So this is one of our key advantages, and this applies to any company in the world which is doing analytics, that if you are able to train your models on large quantum of data, your models tend to be more accurate and you can also deliver them faster compared to the competition. So this is about the different types of modeling that we do. But coming to how the modeling is done, it's a simple step of first understanding the battery and the associated linked systems. So we create a digital twin in the cloud of the battery. So every single battery that is being used by our customers, it is replicated digitally in the cloud with all its component and all its processes. And also we take data from the application and the environment. So suppose you are using batteries for energy storage and you're supplying it to the grid. Then we take the data from the grid for what was the load on the grid, what was the price on the grid for the energy market, what's the load forecast. Environment data can also be included, like the weather conditions, because climatic conditions have an impact on how much energy will be required from the grid. So people turn on their ACs and the generation is not able to match the demand, so you need batteries to fulfill the gap, and then you can model this entire picture as to the impact of weather on the grid and the impact of grid demand on the batteries. So then you have a holistic model of how the system behaves. Yeah, so we have trading data, we have weather data. For electric vehicles, we can also include surge data. So for example, when in the peak hours, office hours, you have a large demand for Uber and Ola, such kind of cab systems. So when they are using electric vehicles, they need to keep the vehicles charged up so that when you book a cab, and when a lot of people book cab at the same time, there is enough inventory of cabs which are charged up to be able to fulfill that demand and cover the distance on the road. So then you can also model data coming from the demand patterns in a city, in different localities of the city for electric vehicle fleets. So these are the kind of data that we take in. And what we do with this data is the next question. So there are 4 types of outcome that can be achieved. And these are the 4 types of analytics in general in the industry. Descriptive is what has happened so far. Let me actually take an example analogy here so that it's clear. So suppose you go to a doctor and the doctor asks you to get a medical test done. So the descriptive report is simply telling you that, okay, you have high fever or you are feeling tired. And then diagnostic analytics is what is the causal factor. So when you go to the doctor and when you take a medical test, it may tell you that your glucose is low, or it may tell you that you have any particular infection. Predictive is what may happen. So the doctor or the test report can say that because your glucose is running low, your insulin is high, and then it may lead to, there are chances that there is 20% probability of diabetes after 10 years. So that's predictive. It's talking about the future based on the past data. And prescriptive is what you should do. So literally a prescription telling you to maybe control your sugar or change your diet so that you can avoid the consequences. So we apply the same kind of analogy to battery management. So you can get to know if the battery is declining in health because lithium-ion batteries fade in their capacity over time. And why it is fading? Is it because of high temperature? Is it because of extreme discharge conditions? Predictive can tell you if the battery may meet its end of life in the next 5 years or in the next 10 years. So because batteries need to be replaced after some time once their capacity fades. And prescriptive could be what you need to do in terms of operational changes or in terms of design changes in the battery so that the battery doesn't really fade out in capacity very soon and it lasts a longer life. Yeah, so these are the kind of work that we do. So I think I covered the next slide, which is the degradation of battery. But it could also be in terms of downtime. Downtime is another critical business use case. You don't want your batteries to be sitting idle. You need them to be running all the time. So you can find out why the batteries have a downtime, how to prevent the downtime from happening, what actions you should take. Yeah, so these are some of the use cases. I have more backup slides, but I will stop at this point for any questions or comments, and I can use the backup slides to answer those questions.
Harsh?
Yes. Okay. I guess we can roll into some questions. I think they're going to be sort of tied to both topics. Um, the first one I have is on, Edison Analytics. So the different strategies, right? The strategy planner, the dispatch optimizer, predictive maintenance. Uh, Sort of touched upon it, like how uh, can you share a bit on all these strategies?
Okay, let me take dispatch optimization as an example. This is a use case which is mostly relevant to markets in California, New York, Texas, a little bit in UK, but it's not yet a common need in India because we don't have an energy exchange operating. So if you look at California market, in California we have an organization called California ISO. What the ISO does is that it matches the demand with the supply, and it's like a stock exchange for energy. And when it is matching the demand and supply, it is also able to tell you at what price will the trading take place. So what dispatch optimization is about is to find out the best price at which a battery should dispatch its energy into the grid so that it can fulfill the demand and it can get the best prices. Uh, so you can imagine that if you are owner of a large battery portfolio, and these are in gigawatt hours. So if you own 1 gigawatt hours of battery, you would have invested 400, $500 million. And now you want to make sure that you get a good return over investment. And for that, you want to make sure that whenever you sell energy into the grid from your batteries, it is getting the best possible price. So instead of $30, you want to make $50 in the market, just like stock trading. And what analytics does here is that it keeps the battery ready for the best prices in the market. And also, it makes sure that when the battery is actually sending the energy into the grid, it is not getting degraded. It is not losing its capacity. It is not under stress. So dispatch optimization is about making sure that the batteries health are intact, batteries perform well, they don't have a downtime, and they're charged up for the best possible time to dispatch into the market and get the maximum money from the market and improve your business ROI.
Okay. And I'm guessing predictive maintenance sort of ties into everything, right?
Absolutely, yeah. Predictive maintenance is everywhere. The key about predictive maintenance is that can you, with some degree of confidence, predict any downtime or any failure or any safety related event? And to be confident, you need to have a lot of data on which your models are trained. So it's very easy to predict a downtime, but it's very difficult to predict a downtime with high accuracy. And it's all about accuracy here. So yeah, predictive maintenance ties into all the areas of business, right after post deployment for things like safety, downtime, even degradation. But the key is how accurately can the analytics predict these events.
If you don't mind, sort of a add-on question to that last part. When it comes to, and again, that predictive maintenance would be a big part of data analytics, right?
Yeah,
Without IoT, without being able to be getting data over the air, these things wouldn't be possible. So
yeah.
when it comes to clients, fleets, OEMs, for that matter,
Mhm.
how does that part of the equation work out? From having access to the data to do that predictive maintenance, how does
Um,
that? Yeah.
it's a two-way process. The first step is to, if you think practically, the first step is to build a use case of what are the downtimes or what are the failures which are difficult to predict. So some of the downtime or some of the failures can be predicted because they are at a regular pattern, and you have some idea of, if I do this, this may happen. But the step one where analytics enters is to find out what are the most difficult to predict areas of failure, and then train the model on the past instances and correlate them with all the other data points. So for example, if a downtime was caused by high voltage event, so then you have to look at the data and figure out what were the possible high voltage events which triggered this particular failure and train your model. Step two, answering your question, is then being able to get this alert down to the operators, because even if you know that there is a possibility and the operators don't know, then it is useless. So sending timely alerts and notifications is one channel by which these operational improvements can be actualized. The second area that is coming up is a firmware update over the air. So if you find a systemic issue which is causing the failure, it's not an operational or a manual area of improvement. You know it's a firmware issue or it's a design issue. So especially if it is a firmware issue, using IoT stack, you can send an update, roll out an update back to the vehicle or back to the battery system, like Tesla does, and then you can avoid these downtime in the future. Does that answer your question, or was it something different?
Yeah, I think it does. It does. This whole, I mean, the maintenance side of things is two-pronged, right? One is, I mean, just like your iPhone, you have issues, or no, not issues, more like software improvements that are coming from ion energy, and then of course you're also looking at issues happening in the field at the customer, which can be pretty unique. So those are also being tracked. Makes sense.
Yeah.
Okay, great. And I guess then my next question is often talked about, doesn't matter what field you work in, but especially with it being a very cost intensive product in general, there's always for any outfit for that matter, there's always this between level of detail and engineering versus the commercial sense of it, right? So from a scale of 1 to 10, like how difficult do you find it? And again, yours is a very sort of a global outfit, but I'm going to try to focus on India, I would say, because I think we identify as a very value conscious.
Yes. I can't hear you.
Just a second, sir. Let me coordinate with this. Harsh, sir, we are not able to hear you.
Am I audible now?
Yeah.
Yes, sir. Yes.
Okay, sorry. So yeah, on a scale of 1 to 10, how difficult it is has it been for you to balance it out? And maybe if you can, highlight a feature or two that helps provide the customer, that balance in detail and commercial viability.
Sure. That's a good question. And yeah, it's a very correct assessment that in India the market is very cost sensitive. The objective is to maximize the value from any service. So the key to rate on a scale of 1 to 10, I think in India especially, it's a higher number is higher challenge, right? So 7 or 8, it's more challenging. In US or in California, it would be 3 or 4. So in India, it's much more difficult to balance the equation between cost and the returns, and that's where the solution also comes. So the problem is that how can an Indian customer get the best ROI from the investment they are making into analytics or any other service? And that's also the solution, because if it is a question of optimizing returns, and if you spend 1 and get 5, then you don't worry about the 1 that you spent. You are just trying to see if the 5 number can be improved to 6 or 7. So the way we solve this problem is to focus at areas where our customers face the most challenges. So how can we use analytics in those problem areas, those surgically identified problem areas, and then try to get the best results in those areas specifically. So to give an example, like I was talking about electric vehicles, as more and more EVs, especially the micro-mobility segment, smaller scooters, they get rolled out on the roads in India. There's a need to optimize the fleet and make sure that the vehicles are available at the right time, at the right place, and they are charged up, and the batteries don't fade out before time. So in order to improve this, you can use analytics, and the returns on this use case are immense. So if you're able to improve your customer experience by providing scooters with the right range, which don't stop in the middle of the road, uh, where you don't need to replace batteries very frequently, then you are improving the business immensely. And that's a very high return over investment, because your customers will be happy, your costs will go down, uh, you will be able to make a better brand name compared to the competition. So our focus and our approach to solve this challenge of making both the ends meet in Indian market is to find out the problem areas where the results, the return over investment can be highest, and then work towards those areas while paying less attention to the other areas where the return could be low. So we're trying to optimize for the ROI instead of trying to bring down the cost.
Makes sense. Absolutely. Okay. I think my next question is more with the advancement of tech in this area, especially with BMSs. Actually, I'm not sure if you or Suraj, either one can take the next question, but from a wireless BMS, we recently saw this announcement that SAE finally has a standard for it, and you know, but it still seems like a very daunting task to be able to have a wireless BMS which is mass market, right? Can you highlight some drawbacks, hurdles, or challenges in getting to that point, and how is Ion Energy actively working in this area, or is it still a while away?
Suraj?
Yeah, I'll take this up. So yes, actually a very good question on wireless BMS. It's definitely an upcoming area with a mass market. So to answer this, we have to understand wireless BMS is just not a device wherein you put some transceivers and get the data directly out of it. So to build it, it requires to build the whole ecosystem wherein you can access the vehicle through your palm, and if not directly on your mobile devices, or maybe directly to your computers via transmission control units which are fitted inside the vehicle. So Ion has the platform already available with transmission control units wherein you do not require a wired connection with the batteries to extract the data. And not just that, um, Ion is also working with a few giants and Indian OEMs. I will not I cannot reveal the names, but um, with them, Ion is helping them develop this ecosystem and attain some of the features that I have to show you, which are more towards an authentication, implementing the authentication within the battery. So in my view, the future isn't far. Um, we might see we might see some of the implementations in the market very soon, maybe this year itself.
Okay, nice. Um, do we expect to see them? I don't know if you can answer the question, but do we expect to see them in the OEM? I mean, in what any specific application category? Say two-wheelers, three-wheelers, or that's something that it's better find out when it comes out, sort of a thing.
Well, we can expect it in two-wheelers, but further information is something I will have to restrict myself, to
That's
give
all
you
right.
details on. Yeah.
Okay. So the next one is to both you guys. If you take, navigate the website of Ion Energy, even if somebody who doesn't know anything about the company and is trying to understand or look it up, there is some really, really interesting case studies of deployments that Ion Energy has, across the world. Uh, Let it be e-bikes or stationary storage or OEMs, like, vehicle OEMs. Uh, can I ask you to maybe highlight or pick a project that is, either ongoing in India or has been completed, something of a case study that you can share with us?
Um, Suraj, you have an example from Indian market?
Um, Maybe I'll restrict it from the Indian market right now because the data is not so available publicly. But then
How
I would
about
say we are.
an example that maybe it's not deployed in India, but would be a great thing to have in the Indian market? Maybe it's deployed somewhere else right now.
Hmm. Um,
So yeah, Indresh, if you want to take this up, or shall I?
um, what do you have in mind, Suraj? Do you have something from the European market, like the scooter or bike examples?
Yeah, absolutely. So I was about to mention the same point, the way I answered in my in the previous question you asked. Um, I is working in one of the very exciting project, um, and it will be for Indian market. We're going to see, um, I'll, we are helping a few of our customers in achieving some amazing features for the two-wheelers, and those are um, uh, those BMSs and battery units will be functional safety compliant. Um, uh, they will have authentication features so that you just cannot hot swap the batteries. And these are the exciting features that I have never seen any Indian OEMs or anybody right now have implemented. So Ion is helping their customers build it, and as I mentioned, we might see something by end of the year or start of the next year. And how this is going to help is basically it will really accelerate the transition of India from to towards the electric, um, in all electric future. So of course Ion is committed towards it, and to have this, Ion also is offering very exciting roles. So I'm taking this opportunity to announce is that Ion is basically offering a challenging and exciting roles that it's calling talented people to come and work with us, work with the amazing hardware and firmware work we are doing, the amazing system integration that we are doing within a two-wheeler and three-wheeler ecosystems. So I know that I haven't been uh, revealing a lot of info about the projects, um, but then this is the max I can push myself to reveal.
That's all right. That's okay. I think it's lost transmission there. Okay. No, I that's completely understood. We don't expect you to divulge a lot of information, but we also have to ask you. So, um, and that's great. We'll make sure that's very nice to hear that Iron is open to new talent, and Gyaniki and Tech Talks can definitely help connect the two. So for sure. Okay, I'm going to roll into one or two audience questions, and I believe the first one is to do with data analytics again, so Edison Analytics. Uh, the question is from Soma Sekar, and he's asking, have you done any data analysis to predict degradation of state of health with fast charging specifically? Uh, and his follow-up is, are there any chances or cases that the analytics have led to a recall of a product? Maybe not name the product, but just
No, no. Okay. Right. So, Somashekar, on fast charging, let's abstract fast charging into high C rates so that we don't have to talk about specific applications. So, in in uh, in both the applications of stationary storage and EVs, higher C rates are known, and we have evidence that higher C rates lead to faster degradation. But higher C rates are not the biggest contributor to degradation. What we have seen is that other factors have a more important role to play. For example, the resting SOC or the temperature. So the contribution towards degradation from C rates is comparatively low. Coming to the second question about recall, I don't know of any such instances because recall is a last resort, right? Recall is when everything else has failed and then you have to admit to the wide market publicly that you screwed up. So re- re- recalls are very rare. I don't know of any such instances. Um, Instead, what we have seen customers doing is to make hot fixes like roll out firmware updates, change the design, replace some of the systems. So yeah, I think the go-to strategies are replacements, updates, fixes instead of recalling. Maybe because that it was not so bad that they needed recall anyway.
right. Yeah, and I guess the analytics are there to actually help prevent any recalls. So it makes sense. Yes. Uh, okay, I don't see any other questions that we haven't addressed already. Okay, there's one. Okay, let's just see. Yeah, there's one from my end, I guess, because we still don't. Uh, so we know that for high voltage applications, in most cases, along with the BMS, you require, and again, I'll let the experts get in detail here, but you do require a power distribution unit, right? You need some switching circuit, as anywhere where there is charging and discharging involved, separate paths. There are some BMSs out there that have tried to switch between the two over CAN and not require a physical contactor. High circuits with high current flowing through them, so contactors become sort of a must. Any thoughts here on whether you know there is a possibility that we might see BMSs develop to a point where everything is on board, you don't require that physical contactor or switching anymore? Any I know it's a very specific question, but it's something that we've also have faced recently, so why not ask the guys who work on it all the time?
Suraj can take this up. I am not
Yep,
an expert in this area.
yep, of course. So, talking about the possibility, it's no more actually a possibility, but it's a reality. So, we have a low voltage system called we call it FSLT. If you will also find it on our Ion Energy's website. So, if I have to give you a trend, usually if the power delivery is 5 kilowatt or less, it always is beneficial that instead of going from a contactor relays, uh, we should go with a solid state power distribution unit or solid state PDU, SSPDU. The reason being is not just it reduces the size, but it reduces the cost by a lot of margin. So it's not just that there is now a possibility that we are looking for, but Ion has the product developed, full-fledged, working, and a proven product in market, which has no contactors, but solid state PDUs for low voltage systems.
Okay, great. So yeah, so we're basically saying that yes, at least for now, for very high, for higher power systems, a PDU or a traditional PDU still works, still has to be there, right? Because that's where your semiconductors may not be able to support the high current in the system. So if I'm saying it's a bus with a BMS, then I am definitely still going to require a physical PDU, like, or the, what do you call it, a more conventional PDU with contactors.
Right.
Okay.
So
Okay.
what
Yeah.
ion energy finds out is that usually above anything which is above 5 kilowatts will end up requiring a traditional PDU, looking at the size and the cost constraints.
Okay. All right. So guys, I think I have probably overshot the time here, but I'm going to address one more question from the audience. I hope that's okay. Uh, so this is from Mihir. Any specific features that you look into to understand degradation patterns of batteries? And his follow-up is, or actually like extended question is, can you predict with some fidelity about micro short circuits or lithium plating related sort of stuff?
Okay, I can take this up. Mihir, since our approach is mostly data-driven and less physics or empirical-driven, we don't get into don't get into the details about if it is related to lithium plating or if it is uh, a micro short circuit. Instead, our approach is to, because I'll explain why. It's because if you get into this physical layer or chemical layer, then you have to take into account all the differences in chemistries and all the differences in how the batteries are configured and assembled. And there are so many different types of batteries, different chemistries, different makes, different cells, that it becomes very complex. The advantage of using data analytics, especially using data-driven modeling, is to get to a higher level. On a higher plane, you can figure out patterns in degradation without having to go into this detail. Uh, so when we use neural networks for estimation of degradation, or we use other empirical methods for this kind of analysis. Those at that plane, the underlying stuff about uh, plating or about short circuits, those are abstracted. And on that higher plane, where the neural network is trying to figure out the different weightages for different components, like the curves for current or voltage or temperature, then it can develop the model out of these raw data. And then at this higher plane, you can apply it to any battery, any chemistry, and it will work. You'll need to retrain the model for different chemistries, but mostly you are agnostic of the chemistry or the cell model and the cell make. So our approach is to build that data-driven model, and hence we don't get into this detail. But we can predict the overall degradation and the causal factors. Uh, that is still the outcome of the model.
Right. Yeah, I guess that definitely makes sense. At a very core level, every component would probably get. I mean, if there is a failure, then it gets looked into in extreme depth at that hardware level, and that's true even for ICE applications right now. So, okay, I think let me see. I think Mir has. Again, I'm
I can.
sorry for going further,
Uh,
but Mir has one follow up. He says, "How difficult is it or tough is it to understand uh, or compare field data, so that's at a system level, versus lab data, which is at again a component level? How difficult is it to compare?"
Looks like Mihir has a lot of on-ground experience. Yes, Mihir, that lab data is completely different from the actual on-field data, both in terms of the data quality and in terms of the sheer number of parameters that you can capture in the field. So to give you a quick example, if you are dispatching into the grid, then you have the grid market prices or the load forecast. In the lab data, it's there's no such thing. It's only the battery being cycled under different conditions. Um, so understanding field data is actually easier compared to understanding lab data, because there you can do multivariate analysis. You have the entire picture of how the system is behaving under different conditions. Lab data tends to be more simple, but because of its simplistic nature, the result that you derive out of it are also less useful. So I would say it's more fun to use field data compared to lab data.
Okay, thank you for that, Indresh. And he says that's an interesting answer. Thank you again.
Thanks, Mihir.
All right, guys. I think we've sort of come to a close for today. Again, both Indresh and Suraj, I really appreciate you guys taking the time, and both your sharing information with us, as well as answering questions in a very frank manner. And also, I think a lot of people got educated today somehow, one way or the other, and we appreciate that. Thank you so much. Before we close out the session, is there anything you'd like to share with the audience? A few parting words, maybe.
I think Suraj covered the part about our hiring, so you can take a look at our website's hiring page, the careers page. We have a lot of open positions right now, especially in engineering. So do take a look, share with your friends. I think, on the session, I think this was a great session. I liked it too. A good start to the day, uh, and some really good questions from Mihir, from Somashekhar. Uh, yeah, so it looks like the audience has a really good understanding of how things work, and it was very interesting. Thanks for organizing this, guys. Thanks, Harsh.
Absolutely. Thank you. My pleasure. And since you did mention, again about the openings and how people can reach out and look up for those openings, I'm actually going to post a question from the side of suppliers out there, and I'm sure that we get a lot of them who attend our tech talks, and again, it's all about opportunities, right? So let's say if there are people in the field of again, the whole Atmanirbhar bit about it. Companies or outfits that are doing any sort of hardware related work in the battery area. Can they also reach out and connect with Ion Energy to see if there are any synergies there?
Yeah, absolutely, absolutely. So we are in the entire technology stack of batteries, starting from hardware to firmware to software and analytics. So yeah, absolutely.
Great. And from a hardware level as well, right? Because we've had some inquiries for things like bus bars, cell holders, people who are trying to do things, indigenously. Those sort of things as well, or is that still a lot of that part of the equation not in India, not based out of India yet?
Suraj, can you answer that? I am not sure about it.
Yeah, so absolutely, Indresh. So, from as far as the battery design is concerned, so the physical design is concerned, maybe this is not tightly coupled with the BMS design. So, Iron has done the battery design also in the past, but right now Iron is more focused towards the system design and the electronic design using the BMS.
Understood.
So as far as bus bar design is concerned, this is not so much of the focus right now.
Okay. All right. Thanks for that, Suraj. And all right, guys, then I guess we will go ahead and close it out again. Thank you very much for taking the time. I hope we can stay in touch, and I also hope that you guys, whenever you find some time, maybe you can join again for other sessions. Every Saturday, 10 a.m., something or the other interesting is happening.
Yeah,
Uh,
sure.
right. With that, thanks the audience as well, and we'll look forward to seeing you next Saturday.
Thank you. Bye bye. Have a good day. Good weekend.
Thank you.
Thank you.
Thank you.
Thanks a lot.
Thank you. Bye bye. Good day.